Hello, everyone. Welcome to the Seric Papers. Today I want to revisit the Einstein's so-called miracle paper of 1905. And I wanted to show you a couple of really interesting things. So basically there's three major conclusions that I would like to share with you. First of all, he clearly states the speed of light is constant regardless of the emitting speed. Nothing really particular here because this was kind of proven in the Michael Morley experiment in Chicago in the turn of the century. I've looked at that Michael Morley data. It is kind of conclusive, but not 100%, I have to add. The second conclusion that he takes here is that the Lorentz transformation is based on the term the speed of light c plus the velocity of a moving system. So this is the kind of the most interesting thing because he clearly says that the speed of light plus a velocity v is possible. Thus, Einstein does not really eliminate superluminal speed or see the speed of light as a universal speed limit. So anyway, I've added here the link to the English version of this Einstein 1905 papers of the Annales de Physique. And wanted to point out, though, that I am using directly the German version here to decipher what Einstein means and what he does not mean, just to make sure that there is no mistake in translation. So basically, after he explains how he measures a system in the stationary system, he then goes to his paragraph 2, where he clearly states what I originally mentioned, that the speed of light is independent of the speed of the source of that light. And so he basically says that anything faster than light is not possible for light phase velocity, also Ausbreitungsgeschwindigkeit. So again, his definition of velocity is the light path divided by the time interval for that path. So then he moves on to the moving system. And here basically, and I've drawn this out, what he describes. He describes a metal rod, and on this metal rod, on each end, he puts a clock. And on top of that clock, he puts an observer. And then he sends a light signal from A to B, and that signal is then reflected back to A. And so he doesn't really explain in what direction that rod is moving, but it seems to me obvious that if the rod, and he clearly states the rod is a fixed length, has to be moving in the direction that I've shown here, because the signal will take longer to arrive flying with the direction of the moving rod. So then that's why you have c minus the velocity of the moving rod. And remember, with Einstein, the capital V is the speed of light. So of course, when you're sending a signal back from B to A, or the signal is being reflected, then basically that signal arrives at A a lot faster because A is moving towards the signal. So that means, of course, that he has to add the velocity of the signal, which is the velocity of light, plus the moving rod. So here you see the kind of astonishing term, c plus v. So that clearly shows that Einstein does not see c as a universal speed limit. He actually calculates that the arrival of the signal, the time needed for the signal to arrive, would constitute something that is faster than the speed of light. Interestingly here, and this is not quite correct, that moving rod has a fixed length out of the stationary system. It should not. I'm just pointing that out. In the logic of relativity, it should not. And he clearly states that it should not. But here for this equation 1 and 2, he uses a fixed length. So I just want to point that out because later I'll get back to that a little bit. So then we go on to his paragraph 3. He explains that there are two systems that he wants to look at. One is the stationary, which I have used the red coordinate system, and then the blue is the one in motion with the starting point or the 0 point being k, small k. So then he goes on, doesn't quite exactly explain, this gets a little bit confusing, that the x apostrophe is x minus vt, but he says very clearly that the motion space-time is moving along the or parallel to the axis of the stationary system, which is kind of interesting. I'll show you a little bit later here in the next couple of slides. So, and then he clearly postulates that the pursuing equations need to be linear as space-time is homogeneous. So all these things that now are being talked about, like warping and so forth, should not be allowed according to Einstein. So I just quickly shown that the blue system, which is the motion system, is moving along the axis of the stationary system. And again, the 0 point is small k, and the 0 point of the stationary system would be the large K, or the capital K, sorry. So what he's kind of doing very similar in the equation 3, he says, okay, I have the start time, let's say that would be 0, and it would take me 2 seconds. That would be when the reflected light returns would be 2 seconds. This half of that would be 0 plus 2 divided by half would be 1. So that would be the time it would take from x apostrophe back to k. So that would make sense, right? So, okay. Then we go to his next equation, which is basically the equation 3, and then he multiplies that by the coordinates. And so you can see tau 2 is, of course, the signal going to x apostrophe and the signal going back as in equation 1 and 2. Now you would expect as the T1 would be the equation equal to equation 2, which would have the C minus V, or capital V minus C. According to the equation 2, this should be actually C minus V, because it would be shorter because the light is flying towards the point K. So there is a confusion with his description that the motion system is moving along the x-axis of the stationary system, but the term in his equation would be actually having to be T1 moving from K to X apostrophe. So there is a confusion here, but just for the purpose of this video, I don't want to clarify exactly what could be and where this, or if this is a fundamental issue. I'm going to leave that out for another video. I'm just pointing out that we have an issue. And then the other thing that he doesn't really clarify is what is V? Is it, because basically it would, the only way that I'm using it here is explaining a differential velocity, but in reality he would have had to define the velocity of the motion system, and basically because the stationary system is not stationary, it has some kind of a motion to it too. So he would have had to describe it at least as a differential motion, which he doesn't. But he clearly describes it as a motion along the positive x-axis of the stationary system. So there is definitely something that's not 100% correct here. But what I really want to point out again is that in this equation, he's again using c plus v. So he's again using an expression that is greater than the speed of light. And this equation is the fundamental equation that will lead to the Lorentz transformation. So let's say this is this term here for T1 is correct, and continue on for a moment. Look here. We have again the expression of something greater than the speed of light. So please follow this math and you get to the equation 7. And basically he does the same operation for then the moving system, which equation 9 is the basically the same expression of the moving system. So if you follow this all the way through, then you can see very quickly here how he then derives to the expression of the Lorentz transformation, which I have basically outlined here in blue. So coming to the fundamental conclusion here is that the Lorentz transformation is based on an expression that is greater than the speed of light. So why is this important to me? Because when I'm doing my observations about light, I have come across, and I have shown this in another video, that we must have, or we probably have, a self-sustaining electromagnetic particle wave. And this self-sustaining electromagnetic particle wave would have, of course, its Ausbreitungsgeschwindigkeit, or phase velocity of c. But the actual particles that are creating this self-sustaining magnetic field would have, of course, a root 2 times c. And that would be interesting, because then the fundamental equation of energy is mv square half. But if v is actually root 2 times v, and you then do that, take that to the power of 2, you would have basically 2 times v square. So then you would have m times v, 2 times v squared divided by half, and then you would have mv square. And since v is constant, velocity of light, c, you would have mc square. So this system here gives you a real physical reason why you have E equals mc square. It's not because mass is some mysterious function of energy, or energy is some mysterious function of mass. It's basically because these particles are flying in a helix. And the reason why we create the constant speed of light is because if these charged particles are flying in a self-sustaining wave, then you have the centrifugal force that applies to each particle that has a charge, and the force that holds the charge into this helix wave. And for the simplicity, I've just said, okay, basically the electrostatic force is Q0 times the voltage. And you can imagine here that this voltage is constant, and of course Q0, or the charge of each of these particles, would be constant. So then you can solve this equation in accordance to V square, which equals then the constant charge divided by the constant mass of these little flying particles. And since you have two constants, that V square will always be constant, and that's what we call C square. So here I have this electromagnetic particle wave that easily explains the constant speed of light, and it also explains E equals mc squared in some non-magical way, in a very, very direct Newtonian explanation. It's not a mystery. It's not some fantastic assumption that energy somehow is mass or mass is somehow energy. No, these are two distinct terms, and they should be and stay distinct. So this is why I have explained this whole contradiction within the Einstein papers. And even if you say his math is correct, which I kind of doubt, he does use the term, a term that is faster than the speed of light. So fundamentally, there is no reason to not think outside of the speed of light. And with that, I would like to conclude this video, and I hope to see you guys soon. I think, it's about time that we start thinking outside the box here, and probably not even Einstein's fault here that this whole thing happened, but more and more people are interpreting without it probably having ever read these papers. So thanks a lot. See you guys soon.